You would instantly die. That's not necessarily.
Okay, focus on very large amounts of power. Okay, I don't want to center people out and say who's talking too much, but Sean. All right, 6,000 watts.
What does that say?
Very large amounts of power. 6,000 watts. If I was talking about 6,000 watts, what would be an easier way to say it using prefixes? Yeah, 6 kilowatts. 6 kilowatts. Now, I said before that we often leave light bulbs on and we talk about wattage for light bulbs. So you might have like a 500 watt bulb, or you might have a 45 watt bulb, 500 watt bulb. Oh my gosh, that's a high wattage, right? But a 50 watt bulb, that's doable. 20 watt bulb, doable. This is 6,000 kilowatts. That might be like for a whole house. So sorry, 6 kilowatts. Is that like for an individual light bulb, or maybe for like a whole household maybe? Yeah. Yeah, whole household maybe. Maybe you turn on the washing machine, doing all the laundry, washing the dishes, all the lights on. You got your plasma, your LCD, your LED, and all your other electronics all on at once, and pretend you don't bust the circuit breaker out. Maybe you got 6 kilowatts. Maybe. Okay, so let's suspend disbelief. But let's say you run it all day.
Isn't physics grounded in reality?
Yeah. Shh. This might be our power that we use for a day, or during our day, in our house if we turn it all on. Now, over the course of a day, we've got 24 hours. 24 hours is the same thing as talking about 24 hours times 60 minutes per hour times 60 seconds per minute. And of course, we have this chain of unit cancellations. We got minutes on the bottom, minutes on the top. Hours on the bottom, hours on the top. And so you end up having just units of seconds in the end. But what's 24 times 60 times 60? 86. Oh, you're quick. 86,400 seconds. Now, if I was going to do a calculation in terms of energy, I could say, well, power is equal to energy, change in energy, over the amount of time. So power times delta T, must be equal to the amount of energy that gets consumed in a day in your household. Must be. But when I do this calculation, what they do at Ontario Hydro, they do these kinds of calculations and then they bill you for it later. They would do power times delta T, but they don't sub in the seconds. What units do you think they measure your energy consumption?
Kilowatt hours.
You jumped right to it. It's kilowatt hours. It is kilowatt hours. The power, he knows, he reads his power, he reads his electrical bill. He reads his electrical bill. And he paid attention in grade 9 science, right? Yeah. All right. So power in kilowatt hours, power in kilowatts, 6 kilowatts, times, not time in seconds, but when we're dealing with very large amounts of power, we typically do our time in hours. So over 24 hours. And this is sort of like an industry standard. And we end up getting, what's 6 times 24? 144?
Isn't that K little?
Fair enough. Thank you very much for that, Nick. Valuable input. 144 kilowatt hours. 144 kilowatt hours. Rounding to sig figs. Now, unfortunately, 24 hours, well, that's a defined value, but if that's how much time there is in a day, but if we're getting the bill from the electrical company, it's a measured value, so we might say that it's 140 kilowatt hours. So if you get charged, let's make it a nice round. Well, that's the question, right? You go to the electrical company, going to charge you a rate, 10 cents per what, do you think? Per kilowatt hour. Can you figure out how much you're going to get charged by this energy, or for this energy? That's how many kilowatt hours. That's how much per kilowatt hour. How would you calculate that value? Multiplication. Yeah, so I'd say cost is equal to, let's call this the rate. Cost is equal to rate times the amount of energy consumed. And so the cost for this electrical consumption would be $0.10 per kilowatt hour, and the units get preserved, times 140, well, let's not round it, 144 kilowatt hours. The kilowatt hours cancel out, and 0.10, or a tenth of 144, is $14.4, or $14.40. $14.40. So here's the thing. Maybe you go to the maybe you could go to the electrical company later on and say, hey, wait a minute, I did the calculations as well. And what I recognized was that there was 2 significant figures here and 2 significant figures there. And so I'm only going to pay you $14. How do you feel about that? My physics is fairly sound. What do you think they're going to say? Yeah, so don't haggle significant figures with tax collectors and billing agents, okay? But that's what you're paying. That's what you're paying, honey. Yeah.
So kilowatt hours is like the same thing as like joules.
Yeah, it's like an industrial measure for energy. So it's kind of like joules, but with different base units, with these large values. Okay, because we can convert them quite easily. Yeah, just like what we've done here. Would you like to convert this amount of kilowatt hours into joules?
No.
I sure would. So I want to figure out how many joules I have. Converting, here's the subtopic, converting kilowatt hours to joules. Converting kilowatt hours to joules. We could definitely do it. So 140 kilowatts per hour is really what this means. I could say that's 140 kilowatts per hour, and that's the same as saying 140 kilowatts in 1 hour. Same. Okay? And if I want to turn this into... Sorry? 140 sorry. Oh, I messed up my... I need a new piece of paper.
Oh.
I'm getting distracted. Off topic. It's almost the weekend. Let's start with 144. I'm sorry, I shouldn't have rounded anyway. 144 kilowatt hours. And I would like to turn it into joules. So I'm going to start off with the units. 144 kilowatts. What would I have to multiply that by to get it into watts? 1,000. Yeah. So times 1,000 watts per kilowatt. And so the kilowatts are going to cancel out. And then it's times 1 hour. So times 1 hour, which if I want to convert hours into seconds, is going to be, well, 3,600 seconds per hour. We've done that calculation enough time that I'm not going to do the 60 times the 60. But 3,600 seconds per hour. Hours cancel out. So 144 times 1,000 times 3,600. It is going to be a big number.
144,000 times
518 million.
Say again, Joe?
518 million.
Oh, no, 51.
Oh.
51 million?
Wow.
Oh, there's a disagreement on the playing field.
518 cents.
518. People are second guessing themselves because Sen is usually right. 518 million.
Usually right.
Oh, everybody drops the ball sometimes.
Oh,
All right.
Perfect this season. I haven't dropped anything.
All right, watt seconds. Now, have we talked about watt seconds yet? A watt second.
Unless I wasn't here for something, no.
So, A watt's the same as a joule per second, right? We said that previously. By definition, a watt is a joule per second. So if I have joules per second times seconds, what am I going to be left with? No. Joules per second times second. Seconds on top, seconds on bottom. You're left with joules. Okay? So you've got 518,400,000 joules if you have 144 kilowatt hours. And I think I can see why the electrical company starts to deal in kilowatt hours. This gets to be a big value. Much harder to deal with. And it makes a lot of sense why they use the industrial units that they do. And if you want to put this into scientific notation, we could say that that's approximately 5.18 times 10 to the power of 8 joules. Okay, yeah, but you're never gonna get scientific notation in your electrical bill. So, that's the way we deal with it here in North America. But you can convert between kilowatt hours and joules. It's very doable. This is the method. Some people that like to have the Mickey Mouse approach, they'll say, oh, kilowatt hours to joules, multiply by, what's 3,600 times 1,000? 3,600, add an extra 3 zeros. Can you see what that is? 3.6 million? Some people say, oh, just multiply by 3.6 million or 3,600,000 every time I want to go from kilowatt hours to joules. That's the shorthand sort of Mickey Mouse approach. This is the why of why it works. Okay?